मुलं काय आता हे असे ओपन होत नाहीत का असे डायरेक्टली असं त्यांचं व्हिडिओ का
ते स्टार्ट
काय
करा व्हिडिओ सगळ्यांनी.
हा व्हिडिओ करा स्टार्ट करा म्हणजे मला चेहरे पाहू दे की म्हणजे आपल्याला सर्वांचे ऍडमिशन झालेत का एक 5 मिनिटं करा ओपन. अनुष्का शिंदे, श्वेता क्षीरसागर, अंकिता साळुंके, माया कदम, धुमाळ आपल्या नावं टाका मात्र त्याच्यावर बरं का तुमच्या ह्याच्यामध्ये. प्रियंका माने, माने कदम बरोबर आहे की नाही. इकडं प्रीती काय प्रीती कदम, शीतल क्षीरसागर, योग्यता बागल, श्रद्धा शिंदे. 1-2 मिनिटं करा ओपन तुमचे व्हिडिओ म्हणजे लक्षात येईल की तुम्ही यू आर इन द क्लास. लक्षात आलं का. नाहीतर अदरवाईज तुम्ही आपलं ऑन केलं ना कुठं फिरता असं होईल. तुम्ही असं मला जरा समोर दिसलं एकदा की बाबा तुम्ही आहात आता सध्या म्हणजे क्लासमध्ये एंटर झालेला आहात हे असं लक्षात येईल माझ्या. तर शीतल येते का नाही शीतल.
सर लिव्ह करू मी.
हा एक मिनिट सेटिंग की काय शीतल क्षीरसागरला येते का. शीतल काही केलेलं दिसतंय. यू कॅच हॅलो येते का.
हो सर ऐकू.
पिन करा तुमचं ते हे काय माईक त्यांचं ऑन करा म्हणा त्यांना.
नाही आपण नाही तिच्याकडेच आहे.
तिच्याकडेच आहे वाटतं ना आता हे सर्व. ठीक आहे हरकत नाही काय असू दे. काय सर्वांनी ऍडमिशन घेतलेत का. शुभम तुझं झालेलंच आहे.
हो सर.
हॅलो
हो सर झालंय.
त्याच्यामुळे काय अडचण तुझी नाही. आवाज येतो का.
हो येतोय.
म्हणजे लाऊडली येतोय का मीडियम येतोय का कसं येतं असं. ठीक आहे ना.
हो येतोय.
हा ठीक आहे काय हरकत नाही. ठीक आहे झालं चालेल ओके. Good afternoon, everybody. Just friends, yesterday we have seen the concept of the virtual ground. What are the assumptions and the implications related to the ideal operational amplifier? But in these lectures, in this series of the second lectures, we are going to see the non-inverting amplifier and what is the gain of the non-inverting amplifier. So basically the final expression for the gain of the non-inverting amplifier is AB is equal to closed loop gain ACL is equal to 1 plus RF upon RI. It is nothing but it is the gain of the operational amplifiers, non-inverting amplifier. Before this, yesterday we have catch up the few headlines or the few points related to the applications of operational amplifier, that is the analog building blocks. So just designing and developing the various linear applications of the operational amplifier, every student must know the fundamentals of ideal operational amplifier. What is a symbol, what is the equivalent circuit of the operational amplifiers, then what are the assumptions and implications which are related to the ideal operation amplifier, that is the input impedance, that is in Rn equal to infinite. What will happen? The current does not flow into the op amp. If output resistance R0 is equal to 0, the output power or output voltage does not change the speed of the load or the status of the load. And third assumption is that when open loop gain is infinite, then difference of signal denoted by Vd, which is called as an input signal, which is equal to V1 minus V2, that should be 0. That means open loop gain is infinite, then Vd is equal to 0. That means V1 minus V2 is equal to 0. That is V1 is equal to V2. That means the input terminal V1, that is non-inverting terminal V1 and inverting terminal V2, they are in the same configuration or the same limit. They have the same nature. They are in the same potential. They are the equipotential. This is the meaning of V1 equal to V2. Afterwards, we have seen the concept of the virtual ground, and in the concept of the virtual ground, already we have learned about the difference between the ordinary ground and the virtual ground. And the ordinary ground is nothing but it is a point which have a 0 volt potential and draws the infinite current. So this is a simple concept of the ordinary grounds. And the virtual ground is nothing but it is a point anywhere in the circuit. If the circuit is a discrete circuit, and in the discrete circuit there is a point, and that point is nothing but it is an interjunction of branches, it is interconnections of the two branches or the two nodes, that is called the junction point. That means the virtual ground is nothing but it is a point anywhere in the circuit which have a 0 volt potential but does not draw the current. This is a slight difference between the ordinary ground and the virtual ground, just we have shown. And afterwards we have touched to the gain of the inverting amplifier, which is operated in the inverting mode. Means we have applied the input signal to the inverting terminal, and we have derived the expression for the inverting amplifier, or you have derived the expression for the voltage gain of the inverting amplifier, that is called as a AV, R which is equal to ACL is equal to minus RF upon RI. What is RF? RF is nothing but feedback resistance. What is RI? RI is nothing but input resistance, and that ratio of these two is nothing but gain of the inverting amplifier. This means the feedback resistors and the input resistor, they are some external component, and they can decide the gain of the operational amplifier, and that is known as a closed loop gain of the amplifier, and that gain is nothing but equal to AV is equal to minus upon RI. And already we have seen the physical significance of minus RF upon RI. What the minus sign indicates? The minus sign indicates that output signal and the input signal, they are 180-degree out of phase. That means there is a phase reversal between the input and the output side. Similarly, RF upon RI, what is this one RF upon RI? It can decide the gain. It can decide the gain of the inverting amplifier. So these are the some few highlights which are very important for design the in of the circuit. And yesterday already I have appealed all the students who are absent for these lectures, they doesn't understand how to design the various op-amp circuits in the different configurations as in a linear configurations. So again I will tell all the students that who are absent yesterday, they can go to the 3 assumptions and 3 implications. We can try to understand what is the meaning and the concept of this assumption implications and how it can be implemented in the designing of the various linear analog applications. And what are the linear analog applications? Linear means the output will be changes in accordance with the input. It is called the linear applications. And we are going to design a few linear application as a special cases or special studies. For example, yesterday we have designed the inverting amplifier, and already we have calculated the gain of the inverting amplifier, that is AV is equal to minus RF upon RI. Similarly, we are going to find again the expression for the voltage gain of the non-inverting amplifier, that is 1 plus RF upon RI. We are going to design the other circuit, subtractor circuits, summing amplifier, log amplifier, anti-log amplifiers, differentiator, integrator. That means they have tremendous applications in the arithmetic operations and the logical operations, and the main basic idea are to develop this operational amplifier. The IC chip is to perform the various arithmetic and logical operations, and shortly that chip will be able to operate or the process the ALE computing, means arithmetic and logical computing operations or data. So this is the main task or main objective to develop the integrated circuit IC, that is a 741. So again, while designing these applications, that is say arithmetic operations as well as some logical operations or as well as some waveform generator applications, the student must know some assumptions, implications. Number 2, they must know the 2 types of laws, various laws in the electronics, that is Ohm's law, Kirchhoff's current law, KCL, current entering at the junction is equal to current leaving out the junctions. Then KCL, KVL, that is Kirchhoff's voltage law. Sum of the voltages around the closed loop equal to 0, or is equal to applied voltage. So applied voltage is equal to sum of the voltage across each element of the loop. This is known as a KVL. Similarly, third point is student must know and understand Or must we can try to learn from this one. But we go again. We can open your books or open your say e-books, and you can see that how to apply the voltage divider rule. In the last years, I might think in the last year or the last year in the BSc one, we have seen the KCL, KVL, Ohm's law, voltage divider rule, current divider rules, okay, and some fundamental of mathematics. And by understanding this one, we are able to design the various arithmetic, logical, and waveform applications in the analog form. So this is all about this one. Next, we can join this. Just first, I will share my screen. शुभम येत आहे को
हो सर.
शुभम
हो सर, येते ऐकू.
हा ओके जस्ट I will share my okay is it visible screen
Yes sir.
1 minute okay is it visible
Yes sir.
Yes, sir.
okay 1 minute just will touch with the next lectures that is a third lecture in this series yesterday we have gone through this one okay this is the second lectures yesterday's lectures that is inverting already you've seen there okay 1 minute hello lecture मध्ये hello lecture मध्ये just you can join to the next article from the same unit that is the analog applications linear analog applications in this one just the next application is a non-inverting operational amplifier and in the non-inverting operational amplifier is concerned why it is called the non-inverting op amp since the input signal just we can this one that is a VI. We can look at this figure. It should have the right side. This is a circuit diagram for the non-inverting operational amplifier. At the having the input signal VI, that is input signal, which is sinusoidal input signal, whose frequency ranges from the audio range that can be applied to the non-inverting terminal, that is a plus terminal, so that is known as a non-inverting amplifier. Yeah, according to the input, here you have applied the input. According to this, you can call as a inverting amplifier or non-inverting amplifier. And in this case, we have applied the input signal PI to the non-inverting terminal so that configuration is known as a non-inverting operational amplifier. And again, we can look at this one having the input terminals, that is the V1 and V2. V1 is a non-inverting terminal, V2 is a say inverting terminal, and V0 is output. And again, there is one resistors, that is RF resistors, which are connected between the output voltage and this input voltage, that is V0 and V2. V2 is nothing but inverting voltage at this point, and that point is nothing but it is known as a virtual ground point. What I am saying, just we have learned this one. That means RF resistance is connected this one, and again RI resistor, that is input resistor, is connected in series with the inverting terminal and it is shorted to the ground. Okay, so this is nothing but this is a simple arrangement or circuit configuration of the non-inverting amplifier having two external resistors RF and RI. RF is a feedback resistors connected between the output and the input, and a second input resistors connected between the ground, and whatever the signal which is to be amplified, that signal is applied to the non-inverting terminal, that is plus terminal. So this is nothing but non-inverting amplifier. So this is nothing but non-inverting configurations. Okay, this is all about the circuit diagrams. So then we are going to learn how to find the voltage gain of the non-inverting amplifier, and while we are determine the voltage gain of the non-inverting amplifier, at the same time just we have to apply some fundamental of mathematics or basics of mathematics. Just I have a call, I will recall that is voltage law, current law, KCL first law, KVL second law, and voltage divider rules, and some assumptions and implication, that is R equal to infinity and R0 is equal to 0, and AV, that is voltage gain of open loop gain, is AOL, that is called the AOL. AOL means open loop gain. AOL is equal to infinite. By applying this one, we can easily calculate or determine the voltage gain of the non-inverting amplifier. So this is a simple circuit arrangement for the non-inverting amplifier, and we can look at this one. This is the first expressions. You can see there. Suppose that the operational amplifier is operating in the linear modes, linear stable mode. That means in the middle stable mode. And at the same time, we have to calculate, that is open loop gain. So already we know the basic of the fundamental formula to calculate the gain. Gain is nothing but output by input. The output divided by input. So AOL is equal to Phi0 divided by Pd, where Phi0 is the output voltage, Pd is the differential input. This is nothing but Phi. It is very much regular to the Vi. That is Pd is equal to differential input, and it is nothing but difference of two input signal. Just I have wrote there, that is Phi1 minus Phi2. Phi1 is the input applied to the non-inverting terminal. Phi2 is nothing but input applied to the inverting terminal, and whatever the difference of these two, that can be amplified by the operational amplifier. So that Phi1 minus Phi2 is nothing but Pd, and Pd is nothing but it is the input, and it is known as differential input, which is applied to the input of the inverting amplifier or non-inverting amplifier or the operational amplifier. But as far as you know that open loop gain, already we have calculated yesterday, we have seen that is assumption AOL is equal to Phi0 divided by Pd. We have taken the limit and we have calculated this one. Open loop gain is infinite. This is a infinite, you know that. And if the open loop gain is infinite, at the same time, output have some finite value, fixed value. This is Phi0 have some fixed value, but Phi1 minus Phi2 have the zero values, and Phi1 minus Phi2 have the zero values. That means the gain will become as infinity. We can try to understand at what condition at what condition the open loop gain of the operational amplifier will be comes out as infinity. When Phi1 minus Phi2, that means the Vd input signal is 0, and Phi0 divided by 0, that means it is infinite. I wish to say that the Vd equal to 0 means Phi1 minus Phi2 equal to 0. That means Phi1 equal to Phi2. And Phi1 equal to Phi2 is nothing but, you can look at this right side, and in this right side, Phi1 is nothing but it is non-inverting input, and to which Phi is applied. And that means Phi is nothing but input applied voltage, which is nothing but equal to Phi1. And Phi1 is equal to Phi2 due to this open loop gain. That means according to virtual ground, that is Phi is equal to Phi Phi1, which is equal to Phi2. Means we can measure the potential between this terminal, Phi1 terminal and ground, and Vt and terminal ground. They have the same potential, and that's why I have written as two input Phi is equal to Phi1 is equal to Phi2. Means whatever the potential at across the Phi is the same potential across Phi2. Phi2 च्या इथं सुद्धा तेच असणार आहे. म्हणजे Phi2 च्या इथं काय असणार आहे? It is nothing but Phi. It is nothing but Phi. And therefore, we can look at this side. This is the input resistance Ri. It is shorted to the ground. Ground is a point. Phi2 is another point. And we are going to calculate that whatever the current, that is I1 current, which are flowing through the resistors Ri. What I am saying that, we can look at this one. This is an arrow, and arrow stands for the current, direction of the current, which has flow from the Phi2 terminal, that Phi2 point towards the ground. This is the direction of the current. Means Phi2 have the higher potential than the ground potential, and then we can calculate the current I1, through which the current I1 will be calculated according to Ohm's law, the difference between the 2 points. This is a Phi2 is a 1 point and ground is another point. And we can take the difference of this potential difference between the 2 points, that is Phi2 minus ground means 0 volt, divided by Ri. This is nothing but current flowing through the Ri. Then I1 is equal to, current flowing through this one, I1 is equal to Phi2 minus ground potential is 0. That means whatever the voltage across Phi2 is, it is nothing but Phi. Since Phi is equal to Phi1 is equal to Phi2. म्हणजे whatever the voltage across Phi is nothing but voltage across Phi1, which is equal to Phi2. Means the potential at Phi2 point with respect to ground is Phi. Here Vi is a side, तसं हे Vi इथं आहे, and that means Vi minus 0, Vi minus ground potential divided by resistance Ri is nothing but current flowing through the resistor. So this is a very important to understand the students. If we able to calculate the how to calculate the current which are flowing through the resistance Ri and current flowing through the resistor Vf, then we can easily calculate the voltage gain of the non-inverting operational amplifier. So we can, Shubham Lakshat ala ka? Are you understand how to
Yes,
calculate
sir.
the current which are flowing through this one?
Yes, sir.
आणि या येतं ना लक्षात, कारण हा फिटो एक point आहे, त्याच्यानंतर हा ग्राउंड पॉइंट आहे आणि आपण एखादा कंडक्टर असेल, यू कॅन ट्राय टू अंडरस्टँड वन ऑफ द एक्झाम्पल इज दॅट देर इज अ वन कंडक्टर इज देअर. एक कंडक्टर्स आहे, वायर एक कंडक्टर्स आहे आणि हॅव्हिंग अ टू टर्मिनस, एक छोटा कंडक्टर घेतला एक 10 सेंटीमीटरचा, यू हॅव टू एंड्स, ए एंड आणि बी एंड. The potential at A end is VA, potential at B end is VB, and we have to calculate the current flowing through this one. तर कसं कॅल्क्युलेट करू शकतो आपण? करंट त्याच्यामधला करंट इज इक्वल टू पोटेन्शियल डिफरन्स बिटवीन दीज टू पॉइंट्स डिवाइडेड बाय रेजिस्टन्स बिटवीन द ए अँड बी टर्मिनल, म्हणजेच VA मायनस VB डिवाइडेड बाय R is the resistance of between the 2 points. Manjes current which are flowing through the conductor I is equal to VA minus VB divided by R. R, what is R? R is nothing but it is a resistance between the two terminals of the conductor. Two terminals म्हणजे कंडक्टर किती आहे? इट इज अ फायनाइट कंडक्टर आहे. इट हॅव सम सर्टन लेंथ 10 सेंटीमीटर्स आहे, म्हणजे हॅव्हिंग अ टू एंड्स, ए एंड आणि बी एंड, आणि ए एंडला A point म्हटलेला, B end la we can say another point B, and the potential at A point is a VA, potential at B point is a VB, and difference of this one is VA minus VB divided by R is equal to current which are flowing through. This is nothing but this is the Ohm's law. According to this, by using the same principle, same laws, we have to calculate the current which are flowing through the resistance Ri, current flowing through the resistance Rf. Here we can look at this one, only there is a change in terminology, there is a change in the notations, change in the directions. Here is a V2 point is there, and this is another ground point is, and this is the difference. What is this one? V2 minus ground. Okay, divided by resistance kai Rr. It is current flowing through the I1. But the voltage at V2 is nothing but equal to V1, and V1 is equal to Vi. That means the voltage at point V2 is Vi. Therefore, Vi minus grounds of 0, Vi minus 0 divided by Ri is nothing but current I1. That's why I have shown here I1 is equal to Vi upon Ri. What is Vi? Vi is nothing but potential difference across the resistance Ri divided by resistance between V2 and ground is Ri, and therefore current flowing through this I1. Similarly, we can calculate, okay, we can calculate the current which are flowing through this RF, that is IF. RF is a feedback resistor through which IF is flowing. What is the direction of the current? The current flows from the output side V0, that is plus sign, to minus sign towards the input side. And therefore, V0, the point at V0, it is a higher potential, and the point at V2 is a lower potential. Therefore, V0 minus V2 divided by feedback resistor is equal to feedback current. Like that, we are able to calculate the current which are flowing to this one. That means student must be able to determine the current which are flowing through the RI branch, similarly through feedback branch, that is RF branch. And if it is understand for the calculation of the current calculation through this branch, they can easily calculate the voltage gain of the non-inverting amplifier or inverting amplifier, or whatever maybe type of the amplifier is there. Next step is next is the voltage VF. We can look at this side. This is a feedback resistors having the value RF. VF is nothing but feedback voltage, which is developed across the feedback resistor, plus and minus. V stands for voltage, F stands for feedback voltage. Yesterday, I have focused on the concept of the feedback. What is feedback? What types of feedback? Effect of the feedback, like that. I have taken the review of this one. So VF is a feedback voltage. Okay, RF is a feedback resistance. Current direction current is from V0 to V2 is there, and then we can calculate the feedback voltage according to Ohm's law. Voltage is equal to P equal to IR. What is Ohm's law?
V equals
P is equal to IR. Therefore, according to this voltage law, Ohm's law, we can calculate the feedback voltage. VF is equal to feedback resistance into RF. RF into IF. ह्या पद्धतीने तुम्ही कॅल्क्युलेट करू शकता. Similarly, which is equal to RF into IF to RF into, I have shown here I1. Why? Why I1? Since here we can look at this side, this V2 is a junction point. There are two nodes are there, two branches, nothing but it is a junction point. One or more branches are meeting together. That point is known as junction point. V2 is a junction point, and at this junction point V2, the current entering at the junction is IF, and current leaving out the junction is IB. आणि इथून जाणारा करंट जो आहे तो कुठला करंट आहे IB2 आहे इकडे जातो तो टुवर्ड्स द ऑपरेशनल एम्प्लीफायर IB1 towards the operational amplifier. But what I am saying that as far as we can use the assumptions that input resistance between the non-inverting and inverting terminals is infinite, that is Rin equal to infinite, that means the current does not flow into the op-amp and out of op-amp, and that's why I have wrote there IB2 equal to 0, IB1 equal to 0, and therefore our equation becomes as by KCL हे तो वापरेला आपण KCL by using KCL here वापरेला की इनकमिंग करंट कुठले आहेत IF is equal to outgoing current, I1 is outgoing current, IB2 is outgoing current, therefore IF is equal to I1 plus IB2, but according to your input resistance philosophy IB2 is 0, therefore I1 is equal to IF. We can try to understand how that equation I1 is equal to IF having appear here. कसं दिसतंय कसं आलेलं हे लक्षात घ्या, बरोबर आहे का? तर हे कसं आलेलं आहे KCL वापरून आलेला आहे शुभम. KCL माने KCL वापरून आलेला आहे. KCL कसा वापरला आहे? करंट एंटरिंग एट द जंक्शन इज इक्वल टू करंट लिव्हिंग आउट द जंक्शन. करंट एंटरिंग एट द जंक्शन कुठले कुठले आहेत? फक्त कुठला आहे IF हा करंट एंटरिंग आहे. जाणारा इकडून कुठं आहे त्या पॉईंट पासून I1 करंट आहे आणि इकडे IB2 करंट आहे आणि IB काय तो झालेला आहे इट इज अ 0. Why it is 0? Input resistance between the two terminals, inverting and non-inverting terminals infinite आहे. Rin equal to infinite आहे आणि इन्फिनिटी रेजिस्टन्स असेल तर त्याच्यातनं करंट काय होत नाही जातही नाही येत नाही. याचा अर्थ काय झाला की करंट काय असतो तो 0 असतो. और अकॉर्डिंग टू द व्हर्च्युअल ग्राउंड कन्सेप्ट किंवा ह्याच्यावरनं सुद्धा अकॉर्डिंग टू द व्हर्च्युअल ग्राउंड कन्सेप्ट नुसार तर तो किती आहे 0 आहे. म्हणजे IB2 इक्वल टू 0, IB1 इक्वल टू 0. म्हणून याच्यामध्ये करंट एंटरिंग ॲट द जंक्शन इज IF and current leaving out junction is I1, and that due to the IB2 is 0. So that I have wrote the equation here I1 equal to IF. Then afterwards I have calculated the value of the feedback voltage according to Ohm's law. Current flowing through the feedback resistors multiplied by feedback resistors, that is RF into IF. This is the feedback voltage just here. And next step is RF into IF into I1. In the third step I have written is I1, since in the equation number 13 I1 is equal to IF आपण शो केलेला आहे according to KCL, and therefore instead of IF I have written I1 from equation 3. लक्षात आलं का शोभा? इक्वेशन 3 वरून आपण ती घेतलेलं आहे इथं. Then RF is equal to again what is I1? I already calculated the I1 value of I1 in the second equation. I1 is equal to VI upon RI, therefore RF into VI. So this is the fourth equation. Okay, next one is okay. up to this समजलं का इथपर्यंत तुमच्या लक्षात आलं का?
हो सर.
ओके लक्षात माने ओके. आता याच्यानंतर आपण हे किर्चॉफ्स करंट लॉ झाला. आता किर्चॉफ्स व्होल्टेज लॉ आपण KVL पाहिजे आपल्याला. बघा मी काय लिहिलंय वी आर अप्लाइंग द किर्चॉफ्स व्होल्टेज लॉ दॅट इज कॉल्ड द KVL. आता लूप कसं आहे बघा, लूप कसं येते ते पाहिजे. यू कॅन ट्राय टू अंडरस्टँड द KVL कॅन बी ऍप्लिकेबल फॉर द क्लोज लूप साठी. अप्लाइड व्होल्टेज इज इक्वल टू समजा इफ देर आर टू रेजिस्टन्सेस series R1 and R2 and we are applying the voltage P to the two series resistance R1 and R2, and the voltage developed across R1 and R2 is P1 and P2. Then we can apply the KVL to this closed loop. Applied voltage P is equal to voltage across R1 is P1 plus voltage across R2 is P2. Means applied voltage P is equal to V1 plus P2. This is nothing but Kirchhoff's voltage law, that is called the KVL, and KVL is applicable to the only closed loop configuration, and therefore similarly we can find out, we can try to understand which is our closed loop configuration in the non-inverting amplifier. त्याच्यामध्ये कुठलाही आपण पाहिजे आहे तर this is a output V0, the loop starts from the output, then feedback resistance, then here is the current IF V2, from V2 to there here internally connected here V1 VI आणि ग्राउंड. लक्षात आलं? हे क्लोज लूप झालं म्हणजे ग्राउंड पासून हे आउटपुट झालं, आउटपुट म्हणजे प्लस झाला. आउटपुट व्होल्टेज इज V0, इट इज अ पॉझिटिव्ह व्होल्टेज, इट स्टार्ट्स फ्लोइंग फ्रॉम feedback resistor, this one like that way, and to the ground. that is a closed circuit is there. This is closed loop is there. Okay. Since why it is closed, we can start from this point: feedback resistor, feed to resistors, then feed to inverting terminal. Again, there is internal resistance is there. तो दाखवलेला नाही इथं, पण इंटरनल रेजिस्टन्स असतो. अँड अगेन टू द नॉन इन्व्हर्टिंग टर्मिनल V1 applied voltage Vi and the ground. This is nothing but it is a closed loop, and we are applying this KVL to this closed loop, that is voltage law. Applied voltage काय आपल्याकडं? What is applied voltage?
VI.
Yes,
Yeah.
VI, correct. Applied voltage is VI. Here VI is equal to this voltage across between the two inverting and non-inverting terminal. This is a V2, this is a V1, and difference of this voltage is VD. When just voltage across the terminal is VD. Across source is VI. Across the RF resistor is VF, and output voltage is V0. ओके, आउटपुट व्होल्टेज इज 0. तर याच्यामध्ये असे येणार आहे व्होल्टेज लॉ इक्वल टू, कारण काय केलेलं आहे की दिस इज नथिंग बट नेट व्होल्टेज. V0 इज द नेट व्होल्टेज ड्यू टू द ऑल इफेक्ट ऑफ दिस वन. देअरफॉर द व्होल्टेज लॉ इज इक्वल टू V0 इज इक्वल टू, बघा असेल बघा, VI इज अप्लाइड व्होल्टेज प्लस VD इज अ differential input voltage plus VF is a feedback voltage is equal to V0. This is nothing but this is known as a voltage law. Which is called the A law. And हे केल्यानंतर याच्यामध्ये तुम्ही हे ठेवा, व्होल्टेज आपल्याला लॉ केल्यानंतर VD, what is VD? It is differential input voltage. It has 0 value. Therefore, the voltage law will becomes as Vi plus Vf is equal to V0, and then we can put up this value here. या व्हॅल्यू जरी तुम्ही ठेवल्या याच्यामध्ये तुम्ही पाहिला ACL is equal to V0 upon Vi, याच्यामध्ये व्हॅल्यू ठेवल्या, आणि फायनली यात व्हॅल्यू ठेवा काय VI. ओके, VI plus VD plus Vf is equal to V0. The value of the differential voltage VD is equal to V1 minus V2 equal to 0. That means equation becomes as Vi plus Vf is equal to V0. We can put up the values of Vi. आपण ठेवलेला इथं VI ची किंमत कॅल्क्युलेट वर केलेली आपण याच्यामध्ये हे काढून ठेवू शकता तुम्ही, VF ची ठेवू शकता आणि V0 ची, आणि याच्यावरनं तुम्ही सॉल्व्ह केल्यानंतर वी आर गेटिंग द इक्वेशन फॉर voltage gain for the non-inverting amplifier, that is nothing but closed loop gain denoted by ACL. CL stands for closed loop, A stands for gain. ACL is equal to V0 divided by Vi is equal to 1 plus RF upon Ri. I1 झालेला पण it is Ri. So this is nothing but this is the final expression for voltage gain of the non-inverting amplifier, which is equal to 1 plus RF upon Ri. This is last equations, and we can look at these last equations carefully. We can look at this equation very carefully, and we can make some remarks. We can make some conclusion. We can draw some conclusion from this. We can observe that equation. We can observe the parameters at the right side. Right side the parameter काय आहेत? 1 plus RF upon Ri, and left side is gain. And we can make some interpretation between the say left side and the right side parameters, that is gain is equal to 1 plus RI upon Ri. And from these expressions we conclude that the gain, the minimum gain of the non-inverting amplifier is always 1. Is always 1 when there does not exist a feedback resistor. That means does not exist feedback resistors means the output is directly connected to the input with a single wire. That means there is no resistance, but we have connected the output to the input through a wire. At these conditions, RF is not upset, means ACL is equal to, equation becomes 1. That is closed loop gain equal to 1. And from this we conclude that minimum gain of the non-inverting amplifier is always equal to unity, or it is 1. And second conclusion is that the closed loop gain amplifier can be decided by the two external components of the parameters, feedback resistance and input resistance. Again, third point is that we can look at the right side. There is a known negative sign or the minus sign which are observing at the right side. That means closed loop gain is equal to 1 plus RF upon Ri. It is positive. And from this, we conclude that applied signal, Pi, it is nothing but sine wave.
Yes, sir. Mhm. सर आवाज येत नाही.
हॅलो शुभम.
हा सर.
किती वेळ झाला गेले तुम्हाला?
काय म्हणलं सर?
नाही, किती वेळ झाला नेट हे झालं?
जवळजवळ आता 5-10 मिनिटं झाले असतील.
बर बर, कुठपर्यंत तुम्हाला समजलं होतं ते?
ते आपण ह्याच्यापर्यंत जे फॉर्म्युला आपण डिराईव्ह केला ना तो
हा,
तिथपर्यंत समजलं. वन
फॉर्म्युला झाला का एसीएल क्लोज लूप गेन?
हा तो झाला. ते समजलं सगळं तिथपर्यंत. म्हणजे
बर बर.
कसं पण समजलं.
म्हणजे क्लोज लूप गेन इक्वल टू एसीएल इक्वल टू 1 + आर एफ आपण आर पर्यंत आपण आलेलो होतो, बरोबर आहे का नाही?
हा
तिथपर्यंत झालेला आहे. तोच थोडासा मी इलॉबरेट केला होता. ठीक आहे, मी परत प्रेझेंट करतो. 4च मुलं आलेत पुन्हा. ठीक आहे, एक 5 मिनिटं करतो, कन्क्लुजन सांगतो. बरं का. कन्क्लुजन सांगतो आणि मग थांबूया आपण पुन्हा सवाला उद्याच्याला परत जॉईन होऊया. एक मिनिट प्रेझेंट करतो, दाखवतो तुला प्रेझेंट करून, स्क्रीन शेअर करतो. ओके, दिसतोय शुभम?
हो सर.
ओके. हा, इथपर्यंत हा समजलेला आहे पॉईंट. ACL इक्वल टू V0 अपॉन VI.
समजलं सर.
आणि याचं सांगितलं. ओके, ठीक आहे. जस्ट हॅव कन्क्लूड दॅट विदिन द 2 minutes. एक झालेलंच आहे. तर दिस इज द लास्ट एक्सप्रेशन फॉर द नॉन इन्व्हर्टिंग ऑपरेशनल एम्प्लीफायर. ACL इज इक्वल टू V0 अपॉन VI इज इक्वल टू 1 plus RF upon RI. So what is the significance of this one? From this we conclude that the closed loop gain of the non-inverting amplifier is always equal to 1 or unity when the feedback resistance is absent. What does it mean? It means that the output is directly connected to the input with a single wire without resistance. That configurations means it is absent, means it is zero. That means RF is zero, means the equation becomes as ACL is equal to 1. Therefore, we conclude that the closed loop gain of the non-inverting amplifier is equal to 1 or unity when feedback resistance is absent. So this is known as a minimum gain condition for the non-inverting amplifier. This is the first conclusion. Second conclusion from this expression is that we can observe that there is a positive terms are there at the right side. But in case of the inverting amplifier, the gain is ACL equal to minus RF upon RI. On the right side, we have found that there is a minus sign. What it indicates in the minus sign in the inverting amplifier? The output is 180 degree out of phase with the input. That is a phase reversal is there. But in case of this non-inverting amplifier, ACL equal to 1 plus RF upon RI. That means they are the positive terms appear at the output side. Therefore, the output signal is in phase with the input signal. Means input and output are in the same phase. There is no phase reversal between the two sources, input source or the output source. But the output signal, it is amplified. Suppose that, for example, I will take that we are applying the input voltage of the 820 millivolt, that is VI equal to 20 millivolt, and the gain of the operational amplifier, non-inverting amplifier, it is a 10. Then the total output voltage which is appear at the output is 200 millivolt, and the 200 millivolt peak to peak voltage, that voltage nature of that signal, nature of that waveform is similar to this VI. Only there is an increase in the amplitude, but the wave which is applied to the input side, it starts from zero. Sine wave सुरुवात झाली 0 पासून, go to the maximum, again reach to the zero, पुन्हा negative जाते. And same type of wave will be appear here, but the output wave is only amplified wave, amplified signal. This is the only difference between this one. So I want to say that the second conclusion is that the output and the input are in the same phase. And first conclusion is that the gain of the non-inverting amplifier is 1. This is a minimum condition is there. And also we are able to calculate, third is we are able to calculate the gain of the operational amplifier with the help of the some two external components, feedback resistance and the input resistance, that is RF upon RI. So these are the some conclusions from the expression for the non-inverting amplifier. Sometimes we can find that this question is asked in the examination. Sometimes the MCQ type question will be asked there. The minimum voltage gain condition for the non-inverting amplifier is that the minimum gain of non-inverting amplifier is dash. A option infinite, B option minus RF upon RI, C option 1 plus RF upon RI, and last option D option का असेल 1 असेल. तर number 1 is nothing but it is a minimum gain of the non-inverting amplifier. Like that way, we can observe some type of the MCQ type of the questions here. And sometimes if the long question is there, some will be short question is there. Draw a neat label diagram for the non-inverting amplifier. Find the expression for voltage gain for 5 Mars, 4 Mars, And by in addition to the inverting and non-inverting, it will becomes a 10 mark questions. Inverting question, inverting it is a 5 marks, and non-inverting for 5 marks. Totally it will become a big question that is a 10 marks. Like that way we can find some of the questions that is MCQ type, single type. So why it is called the non-inverting amplifier? Why it is called the inverting amplifier? Non-inverting amplifier means whatever the signal which is applied to the input, the same signal will be appear at the output. There is no phase reversal between this one. Output signal is in phase with the input, so that is called a non-inverting. What inverting amplifier means, the input signal is inverted, or there is a phase reversal of 180 degrees, so that it is called the inverting amplifier. So this is the meaning of the concept of the inverting and non-inverting amplifier. Just we have seen yesterday and today, and the next day or next day, or not day, but next week on Monday, just we'll touch with the next article that is called the voltage followers. It is very much similar to that one, that is voltage follower. Just tomorrow, not tomorrow, next week we'll see the voltage follower circuits and other type of the circuits, how to design the voltage follower circuit. काय हरकत आहे का शुभम?
नाही सर.
समजलं का तुला काय?
हो सर, समजलं सगळं.
मला तर मी बाहेर येतो, जरा थोडस याच्या बाहेर येतो, म्हणजे ह्या स्क्रीनला येतो. 2 मिनिट. हा, तर काय अडचण याच्यात असेल तुम्ही पहा, आणि मी तुम्हाला पुढच्या आठवड्यामध्ये माझे तुमचा व्हॉट्सअप ग्रुप तयार केला असेल तर व्हॉट्सअपला मी सॉफ्ट कॉपी पाठवतो, किंवा तुझा मला एक नंबर सांग, तुला सध्या तरी मला पाठवून दे. माझा नंबर आहे का तुझ्याकडं? तुमच्याकडे नंबर आहे का माझा?
मेसेज करतो की तुम्हाला.
हा, मला मेसेज, तुझं नाव टाक, मेसेज कर मला तुझं. मी तुला काय करतो की ते पुस्तक तुला मी पाठवून देतो, ई बुक्स जे आता मी शिकवतो त्याच्यातून, ते तू दररोज तुम्ही वाचाल त्याच्यामध्ये. म्हणजे माझं लेक्चर्स होण्यापूर्वी ती काय असाल तुम्ही थोडंसं वाचून येणार. म्हणजे आपण लेक्चरला येताना थोडंसं ते रिडिंग करायचं, पुढचं आर्टिकल कुठलं आहे, पहिलं काय शिकवलेलं आहे, काय समजलेलं आहे का नाही, तर हे देतो. किंवा माझ्याकडं गुगल क्लासरूम आहे, फक्त तुम्हाला ते ग्रुप तयार करून ऍडमिट करून घ्यावं लागेल. तर त्या गुगल क्लासरूमला सुद्धा सगळ्या पीपीटी प्रेझेंटेशन्स आहेत, त्याच्यानंतर ई बुक्स आहेत, लक्षात आलं का? आणि ई नोट्स, आता जे म्हणतो मी तुला देतो ते ई नोट्स, की आज जर तुम्ही हे केल्या, मी तयार केलेल्या तर त्यावर तुम्ही रिलेटेड वाचल्या तरी तुम्ही चालू शकता, किंवा अभ्यास केला तरी चालू शकता. तर अशा पद्धतीचं हे तुमचं लर्निंग मटेरियल तुम्हाला देतो, की जेणेकरून पुढच्या वेळेस याची लिंक लागेल. नाही तर मी हवेमध्ये शिकवणार इकडून, इयरमध्ये, तुम्ही इयरमध्ये ऐकणार. कोण आता तू थोडंसं ओपन मध्ये जरा दिसतोय, कारण बाकीचे कोण व्हिडिओ बी ऑन करत नाही, ते त्यांचं स्टेटस काय आहे, ते आहेत का नुसतंच ऑन करून बाबा लंच करतात का, काय खातात का, काय किचन मध्ये जातात, काय चहा घेतात का, बाहेर बघतात, असं हे लक्षात येत नाही. तर त्या पद्धतीनं कोण खिडकीत आहे, कोण बाहेर पाहतंय का, तर अशा गोष्टी त्याला पाहायला नको आहेत आपल्या. तर त्या गोष्टी करू नका, शक्यतो हे करा. आपण रिपीट करू. अजून पुन्हा याच्यातून काय अडचण आली तर परत डिपार्टमेंटला तुम्ही जरी आला, समजा काही गोष्टी समजल्या नाही त्या, समजा ऑनलाईन किंवा आता ऍडमिशनच्या काळामध्ये काय विद्यार्थी होते, काय नव्हते, कोणाची जरा थोडंसं आहे, थोडासा कनेक्टिव्हिटीचा थोडासा प्रश्न येतो, नाही असं नाहीये. मी असं म्हणत नाही की बाबा कनेक्टिव्हिटीचा प्रश्न आहे, नाहीये. तर कनेक्टिव्हिटीचा प्रश्न असतो, त्यामुळे काय एखाद्या गोष्टीला समजू शकत नाही, किंवा इकडून बी कनेक्टिव्हिटीचं थोडंसं प्रॉब्लेम एखाद्या होऊ शकतोय, किंवा एकदम हे होतंय, तसंही सांगू शकत नाही. तर थोडंसं काय जे थोडंसं काय मिसिंग असेल थोडंसं, तर ते आपण करेक्ट करूया, किंवा पुढच्या वेळेस सांगा जावं की सर हे इथनं तुमचं मिसिंग राहिलं आहे, परत हे सांगा, ते आपण सांगा जाऊया. तर या पद्धतीने आपण रेपोमध्ये काम करूया ऑगस्ट या महिन्यामध्ये, आणि सप्टेंबरच्या पहिल्यामध्ये हा टॉपिक आपण संपूया. 15 सप्टेंबर पर्यंत, 15 सप्टेंबर ते 15 ऑक्टोबर दुसरा करूया, तिसरा करूया, असं नोव्हेंबर डिसेंबर पर्यंत आपलं होईल. आणि एखाद्या वेळेस जर टर्म्स वेगळे असेल तर परत सुद्धा एखाद्या शक्यता वेगळ्या पद्धतीने होऊ शकेल, असं काही नाहीये अजून, त्याच्यावर ही निर्णय झालेला नाही गव्हर्नमेंटचा. तर जोपर्यंत होत नाही तोपर्यंत ऑनलाईन शिक्षण घेऊया. आणि प्रत्येकाने ऍडमिशन घेतलेत का सर्वांनी? राहिले का याच्यामध्ये? इंगुलकर झालेत का ऍडमिशन? बागल, आपले माईक ऑन करा जरा. हॅलो, का त्यांना येत नाही का? हॅलो,
हा सर,
घेतलेत का ऍडमिशन?
राहिले सर, आज करणार होतो. नेवेकर सरांनी केला होता कॉल, म्हटलं येऊन करून द्यावं.
तर कोणाची बरं का, कोणाची अडचण असेल तर डिपार्टमेंटला या, मी असतो. तुमचं फीचे असेल, ग्रँटेबलची तुम्हाला दिलेली ऍडमिशन आहे, त्याच्यामध्ये कोणाची अडचण असेल तर मी सॉल्व्ह करतो. या तुम्ही सही करतो, मी खाली दिलेला आहे. पटकन तुम्ही ऍडमिशन ही आता या 2 दिवसात झाली पाहिजे. आणि फुल फ्लेजनं आता चालूच केलंय मी, काय आम्ही तुम्हाला काय गप्पा मारत नाही लेक्चर, मी चालूच केलेलं आहे. परंतु तुम्ही यू डोंट मिस युअर लेक्चर्स, किंवा तुमचं ते पुन्हा कनेक्टिव्हिटी राहणार नाहीये. तर त्याच्या पुढचं आम्ही घेत असतो. पुन्हा पहिले घेतलं तर पहिली मुलं म्हणणार हे बोर होते, शुभ म्हणणार आहे, तुम्हाला नवीन असेल तर त्या विद्यार्थ्याचा विचार करून आम्हाला पुढे जावं लागतंय. तर त्या दृष्टीने थोडंसं पटकन 1-2 दिवसामध्ये घेऊन टाका आणि लेक्चरला तुम्ही हजर आहात चला. आणि काय अडचण असेल तर डिपार्टमेंटला या, फीच्या बाबतीत हे असेल तर हे करू, तुम्हाला ई बुकची सोय करू. आणि तुम्हाला बुक्स सांगितलेलं आहे लायब्ररीमध्ये, ती कार्ड वगैरे मिळा, ऍडमिशनचं कार्ड घ्या, 2-2 पुस्तकं घरी घेऊन जावा. तुम्हाला जे पाहिजे ते, ती पुस्तकं कुठली आहेत ते मी सांगतो. ज्याच्यात थोडंसं तुम्हाला हे नोट्स दिसतात, डॉक्युमेंट दिसतात, पण एखाद्याचे दिसत नाहीत, काय मिळत नाही, तर त्याचे पुस्तक ते कुठलं स्टँडर्ड आहे तुम्हाला ते दिलं जाईल. त्या पद्धतीने आपण काम करूया आणि तुम्हाला थोडंसं तोही मिळेल, बेनिफिट तुम्हाला त्या पुस्तकाचा मिळेल. 2-2 पुस्तकं मिळतील तुम्हाला त्या कार्डवर, बारवर कार्डवर. तर या पद्धतीने चालूया आपण आणि थांबूया. उद्याच्याला काय नाही, आता सोमवार, मंगळवार, बुधवार, मंडे, ट्युसडे आणि वेन्सडे देर विल बी 3 लेक्चर्स विच इज अलॉटेड टू मी. मला असतात 12:30, आपल्या 12:25 दुसरं होतं, 12:25 ते 1:25 हे माझं लेक्चर त्याच्यामध्ये असेल. आणि त्याच्यानंतर एखाद्या वेळेस पुन्हा मागं पुढे चालू झालं तर दुपारनं आपण एखादं व्हर्च्युअल प्रॅक्टिकल असेल किंवा फुल स्विंग मध्ये असेल तर एखादा IoT सारखं वर्कशॉप असेल तर त्या गोष्टी आपण करूया त्याच्यामध्ये. एक चांगला द्या आर्डिनो बोर्ड, मी तुम्हाला सांग, अतिशय इंटरेस्टिंग गोष्टी आहेत, त्या पण शिकायच्या त्या. तुम्ही माणसाला हे आणि तुम्हाला सगळ्या मी सांगणार आहे कुठली आपण सर्टिफिकेट देणार आहोत, तुमची फाईल कशी असेल, तुमचा बायोडाटा कसा असेल, तुमची डॉक्युमेंट बीएससी नंतर तुमची फाईल कशी असेल, तुम्ही इंटरव्ह्यू मध्ये कसा जाणार आहात, कुठं तुमच्या पद्धतीने काम करणार आहात, त्याच्यानंतर काय करणार आहात, या सगळ्या गोष्टी मी जर थोडंसं फुल स्विंग मध्ये मुलं आल्यानंतर एक कॉमन लेक्चर सर्वांसाठी मी एक देणार आहे. इलेक्ट्रॉनिक्स असतील, कम्प्युटर असतील, याच्यावरती सगळ्यालाच मी थोडंसं कॉमन आहे. आणि व्हर्टिकली आपण थोडंसं कॉम्प्युटरची काही एखादा मित्र तुम्ही असं मिळून एखादा प्रोजेक्ट करायचा आपल्याला, की याच्यामध्ये पायथन सॉफ्टवेअर लँग्वेज येईल, तुम्हाला बी येणारच आहे त्याच्यामध्ये. आणि तुमचं आपला हार्डवेअर आणि आपल्या असेंब्ली लँग्वेज करून आणि क्लाउड करून अशा पद्धतीचं आपल्याला एक काहीतरी वेगळं इनोव्हेटिव्ह या गोष्टी याच्यामध्ये करायच्या आहे. आणि ऍटलिस्ट हे सर्वांनी प्रत्येकाने एक तर कंपल्सरी आपल्याकडे आहेच ते, याच्यापेक्षाही जास्त घेतलं चालतंय, 2-2 केले चालतात. अगदी तुम्ही शिकत असताना 8-8, 10-10 गोष्टी प्रोजेक्ट छोटे छोटे केले तरी चालतात, फक्त कन्सेप्ट शिकून त्याच्यामध्ये घ्यायचे. तर त्या पद्धतीने आपण काम करूया, त्याच्यामध्ये थांबूया. आणि सर्वांना सांगा थोडंसं अटेंडन्स. आणि मला थोडंसं शुभम जर गेलं जर काय करायचं, माझा नंबर तुझ्याकडे असेल, मला थोडासा फोन करायचा, सर असं झालेलं आहे. काय होतंय, माझ्या स्क्रीन असते, स्क्रीनच्या समोर माझ्या लक्षात येत नाही, बदनात तुम्हाला विचारतो मी तसं की ऑडिएबल आहे का नाही. पण तरी देखील थोडंसं काय वाटलंच, एखाद्या स्विंगच्या ह्याच्यामध्ये मी बोलत राहत असतो आणि बोलत असताना जर तिचं ब्रेक झालेला असेल, एखाद्या वेळेस काय होतंय कनेक्टिव्हिटी जाते इथनं बी थोडीशी, तर त्यावेळेस जर झाले तर थोडंसं सांगायचं. शक्यतो नाही होणार तसं, माझं लक्ष थोडंसं असतं, मधनात मी चेक करतो ते. काय हरकत नाही. गुड डे. घ्या, एन्जॉय करा, करा गौरीची पूजा करा, जेवण करा, पुरणपोळी खा, आईला मदत करा. ठीक आहे, चालतं. ओके, गुड डे. सांगा सर्वांनी घ्या ऍडमिशन.